Hello and welcome back. This is Frank Witmer with Verdi Precision on another CCT, an introduction. Topic today being peer-to-peer communications. Peer-to-peer communications provides communications directly between two devices on a network, whether that is sharing a supply air sensor across the network from a rooftop down to VAV boxes, or it's sharing a space sensor from one controller to another. And there's two ways to do it. You can do it where you allow for a device to read from another device, which would be pulling data from another device. And this is done by configuring the peer reference in a network input point in CCT. Its updates are based on change of value and is the recommended method of doing peer-to-peer. The other method is allowing for a device to write to another device. Basically, you have a network output writing to a input on another controller, and that's basically pushing data out. You configure this in the peer reference section of a network output point. And it updates based on polling, and it's a poll rate of 30 seconds that is fixed. It cannot be changed. And typically this is used when you're sending a value to a third-party device. And some guidelines for peer-to-peer to take into consideration. You don't want to exceed 15 network outputs with peer references in any device. You also do not want to define a single device as the source to more than 50 other devices. So basically, you don't want to have say a rooftop controller sharing its supply air temperature to more than 50 devices, 50 VAVs on a network. And one thing you have to keep in mind is peer-to-peer communications does require processor time, and also it uses up MSTP bandwidth. So you've got all these communications going on between controllers on the network. So the more you have, the more bandwidth gets used up. Basically, the setup is very simple. Really what you do is you need the instance number of the controller or the device that you're communicating with to. And that's the instance number, or the BACnet ID as it's referenced in CCT. The other piece you need is the object identifier and the instance number of the point that's to be read or is to be written to. An example would be analog value 10,026 or analog input value 1019. It could be binary value, binary input, binary output. Any of those object identifiers could be used. And then you would view the details section of a network input or network output that you want to be doing the pushing or the pulling of data. And there is a peer-to-peer section that you would put in the instance number of the controller and then the object identifier as well. And then we'll be showing that live in a CCT session. Our use case here is going to be sharing a discharge air temperature sensor from a rooftop application to a VAV controller. And what I've got opened on CCT right now is a air handling unit application on a CGM type of controller. And what you'll see is I have discharge air temperature on universal input number 1. And while we're in here, we'll also share the supply air fan status as well, and that's the SF-S binary input 2, and we will share both of those with the VAV controller. And as I mentioned previously, you need to know what the instance number is of the controller where you're pulling the data from. So in this case here, if we go to define hardware and then go to network settings, we'll find the instance number for that controller. In this case, it's 1004. The other place to find it is in the lower left corner, where it gives you the MAC address and the instance number for the controller. So we got to remember it's controller instance number 1004, and then we need to know what the object ID is for the points. So if we open up the details of the discharge air temperature sensor and we look at the BACnet area, you'll see here BACnet object identifier. It's AI 1019. So that's going to be the object identifier reference we need in the VAV controller to know where to pull the data from. The other one we're doing is supply air fan status. So if we go in here and look at its details, we'll see that that's a binary input, and the instance number is 1095. So we need that as well to configure the VAV controller. So what we'll do here right now, since this is open, we'll go ahead and commission, and we'll look and see what our discharge temperature is and our supply fan status value is, so that we can, when we finish with the VAV side, we'll look at the data and see that we're sharing correctly. So now we're in commission mode. And once it brings data up, we can look at that. Okay, so discharge air temperature is around 76.3, and we have our fan status on. I have a jumper on that input to show the fan status is on. So we can come out of configure there. And then what we'll do now is we will open up the constant volume, or we will open up the VAV application. Okay, I have my VAV application open now, and what we have is we have two network input points that we're utilizing. We have supply air temp and we have supply fan status. They are the two network input points that are going to be receiving the values from the air handler controller. And if you look all the way to the right here, this icon is signifying that these 2 points have a peer-to-peer reference already programmed in them. And I had previously done that. So let's take a look at them. So we look at the supply air temperature details. We'll see in there, if we go to edit, under peer-to-peer section, there's a peer reference. The instance number for the controller is 1004, and we set up the object identifier as what we found on that rooftop controller. We saw that it was analog input 1019, so we entered that data there as well. We hit apply and close, and that point's ready to go. If we look at the fan status, we look at its details, set up the same way. Again, the controller that we are pulling from is instance number 1004, and the object identifier is binary input 1095. We have those set up properly there, and they will start pulling in the data. So you would go through, do your download, and everything will be running in the controller. And then from there, what we can do is go to commission, and we can take a look and see if we're actually getting the data across there. So if we take a look, it's going out looking for the controller. It's a CVM controller that we're using. So we'll say next, finish. And if we go and we look at our input, network inputs up here, we should see supply air temperature 76.4. So we're getting our temperature across the network, and our fan status is on. So I could turn around and pull that jumper on my other controller. I just pulled that, and now we can watch it update and see if the fan status is turning off, which it should in a second or two. There we go, it went back off again. So that's basically the setup for peer-to-peer with the Johnson Controls FX controllers using CCT. I hope you enjoyed it. Thank you.